everybody. This is the next question that we're gonna solve. So let's go over this. So we are given an array nums. Okay, so we have a nums array. It is array of numbers. Okay, and we have to handle multiple queries of the following type. Calculate the sum of the elements of numbers nums between indices left and right, where left is less than equal to right. Okay, so this initialize the object with the integer array, right? So I mean, the constructor is empty, so seems like it is asking us to perhaps declare a nums array internally, I guess. uh, I don't seem to remember whether we can use private here. Anyhow, let's try to do that and let's try to run it. Maybe that keyword, I just want to see what keyword is allowed or not. Okay, looks like there was no issue. So it is allowed, and yeah, while we're at, why not just give it a type as well? Okay, so once we're here, we should be able to provide the sum in this range. Okay, so in order to do that, how would one do that? Let's go to the whiteboard and discuss it further there. Okay, so we can have an array. Well, this part is really weird, the way they're expressing that. I mean, it's a simple array they're passing. I don't see example of that. Okay, maybe that one. Okay, so anyhow, we can take our own example. Okay, what was this, right? Okay, so we have these options here. Now, let's say 1 and so this is the 0 index, 1 and 2 and 3. So let's say we are asked to provide the sum for indexes 1 and 3, and both those are inclusive. So what can we do here, right? Because some range can be called many times, so I think here it makes sense that we make use of the prefix sum array. So whenever we initialize the array, it will be one time effort that we generate the prefix sum array. Now once we have that, so like the prefix sum for this one would be 1, then it would be 3, then we go to 6, 6 plus 4 would be 10. Okay, when we're here now, we wanna get the subarray sum using this, right? Now because we have sum of this portion and we want to just get this portion, and then of course we have to subtract whatever is here. Now how do we get that? Well, we'll pick the uh, left index, right, which is going to be less than or equal to that, right? So we're going to be okay, let's pick this one if it exists, right? I mean, if we were at 0, then we'd have no room to go back to, right? So that's another thing. But if we have, then we're gonna get the prefix sum for this point. And where would we get the prefix sum from? We'll get it from this array. So we get the prefix sum this one, right? And then we have the prefix sum for this one. So let's call it p1, let's call it p2. So we're gonna get p1 minus p2, and this is going to be the sum that we're going to return, and this is going something we're gonna get in constant time. And there will be just initial cost when we have to create the prefix sum array. So yeah, let's do that. So we'll have prefix sum, and that would be also an array. As for the size of this thing, it is going to be same as the original, so we're gonna have nums dot length. Okay, we get that. Now we have to populate it. Now it makes sense that we create a private method for that, and we can say populate prefix sum, or we can say init. Yeah, that's right. Initialize the prefix sum, right? And what would you want to pass as the array? Why not nums? So that way it becomes, what should we call, a pure function, because it is only working on the params that it has received and is going to return that. Okay, yeah, that sounds good. And then perhaps we can return that as well. Okay, so we have nums. So we're gonna iterate over that. So let's start with 0, I, nums dot length, I, plus plus, and then we have prefix sum. So since prefix sum is same size as nums, so we're never gonna be out of bounds. Now here we need to create a variable cumulative sum is 0, and here we are adding it. So this is going to maintain a running total, and when we have the running total, we're going to save it at that corresponding index. And when we have done that, we are going to return the prefix sum array. Okay, so far looks good. Okay, now we need to call this init uh, init prefix sum, and once we have that, why are we returning it? We're not making use of it anywhere, right? Perhaps there was no need to return it, so let's get rid of it. And at this point, when the sum range would be called, well, we're gonna say if left is greater than 0, right, then we are going to get, well, previous index. But previous index, what would be the value of the default one? We need to think about that as well. So we left -1. So then we're gonna say we need to get the cumulative sum for the right, and then out of that we want to subtract the, well, perhaps we don't need to store it. I mean, we can simply say, okay, if this is true, if this is not the 0 index, then there is an index before that, so we need to get to that and get the prefix sum for that and return the difference. And if this is not true, then that means we are where the left is 0. Well, if the left is 0, what are you gonna do then is simply return left, no, simply return right, and there is no nothing before the left that you need to ignore. But from the code maintainability point, I think there is something missing, because going forward, if we have to change this logic, the maintainer will have to, whoever is like doing that, if it was an actual software, will have to change in two places, right? So for that reason, I would not advise it. But I'm just thinking, is there a way we can do better? We can remove this redundancy, right? That's what I'm thinking on about. So let's say if this is 0, then we want this thing to be just 0, right? How would we do that? Well, we can simply say prefix sum, and we can say if this is left is greater than 0, then we are going to do left minus 1. Otherwise, so if this left is greater than 0 is not true, that means left would be at 0. Then we return 0 here. And what does that do? So this is the condition, and then whatever the I don't think perhaps. Okay, let's add the parenthesis though, just for the sake of clarity. So this is the if part, and this is the else part, and yeah, that's pretty much it. So what do you think? I mean, so far it looks good to me. I haven't done a dry run. I mean, let's review it line by line. So we get whatever we get and we store it, then we create another array, prefix sum. At this point this will be empty, then we initialize it, and we have the cumulative sum, and then place it at the corresponding index, and then we get if the left is greater than 0, then we pick whatever is before that. Yep, looks good to me. Let's see. Oh, looks like it worked. Cool. Yep. And what would be the time complexity of this thing? So for this one, here we are basically space complexity. We are using the additional space, and here we are going to do of n in terms of time complexity. We are iterating over the array, and here this is going to be constant. But then the good thing is that the initialization of the prefix sum does not happen often. It would only happen at the time the constructor function is run, right? So constructor is run, so yeah, we're good there. And yeah, that's pretty much it. So this is pretty performant.